Howdy everyone. In this video I want to talk about a couple bugs in Fusion 360's CAM. I'm going to call these 2D contour feed rate bugs. What they do is they set an incorrect feed rate to 2D contour toolpaths based on the shape of the chain that you use to create the toolpaths. These don't always come up, but they are very predictable and you can work around them. Unfortunately, the workarounds introduce their own annoyances. So I'll try to show the bugs, I'll try to show the workaround, show the annoyances, and then I think I got a kind of a bonus bug in there too. Both of these toolpaths right now are correct. So let's kind of show the little demonstration part I've got here. So I don't know what this would be, but it doesn't matter. I've also modeled out the stock. So let's say we're starting with stock that looks like this. So all we're doing at this point is we're going to rough out and finish this wall here. And we're going to finish the floor in here. Okay. So for the roughing and finishing of the outside wall, I've got this toolpath here. Let me show the tool real quick. Get in the tool library. I've set the feed rate of the tool to 100 millimeters a minute. That's just an easy number. Basically, you can think of that as 100%. All the rest of the stuff doesn't really matter. Okay, so the rough and finish operation is here. Let's show you, or let me show you how I set that up. Basically, I came in, got the tool, selected my geometry, this outside square chain here. Didn't change the heights. I've got a little bit of stock to leave on the floor. That's just to make it realistic. You'd probably come in and finish this floor separately. I've also got it to do the roughing passes. I've checked the roughing passes checkbox. I'm clever like that. I told it to do 2 step overs at 2 millimeters. The step over distance doesn't matter, and the number of step overs doesn't matter. I just did it that way to make it kind of, clear. After the roughing, it'll do a finishing pass at a 0.5 millimeter step over, and the finishing pass will be at 50% of the cutting feed rate, and obviously that'll be 50 millimeters a minute. So hit OK, it'll generate this toolpath again, and obviously what it does is it comes down, does one roughing pass, a second roughing pass, then a finishing pass. Pretty straightforward, and at the moment this exact toolpath, this works correctly. Okay, next I have the floor finishing in here. This I set up in a similar way. Grab the tool, set the chain as this circle here. It's on the inside. I didn't change the heights. I didn't leave any stock because this is a floor finishing. And the stock is also created with the wall finished already, but it really doesn't matter. Okay, and to make it finish the entire floor, I set a step over of 70% of the tool width, the tool diameter I should say, and I told it to do 3 finishing passes. So I hit OK here. What should happen is the tool should come down and finish this part of the floor, then continue finishing and just keep on finishing until it exits the pocket here. Alright, so like I said, these are working correctly, so let's just observe them working correctly. So the tool comes down, starts its first roughing pass here. And we can see that it thinks it's cutting, or knows that it's cutting, and it is doing at the full speed, 100%, 100 millimeters a minute. So it goes around, takes off the the first layer of roughing there, comes around, starts the second layer of roughing. It is continuing at its roughing feed rate as it's supposed to, and continues along. When it gets to here, it starts its finishing feed rate, and when it does that, it drops to the finishing. I mean, it starts its finishing pass. And when it does, it drops to its finishing feed rate. Okay, and it comes around and finishes, and everything is good. Whoops. Then we'll go over here to the floor finishing. And it comes down, and it has begun its finishing toolpath, and it is doing it at the finishing feed rate. So, once again, this is good. This is exactly what it should do. So awesome. Good job, Fusion. Good job, Autodesk. This is doing, everything I'm supposed to. Okay. So we're good here. But let's change the stock a little bit. Let's say instead of having this hole already at the exact size we want it to be, let's say there's a little bit of a wall here too. Now there's 3 millimeters of wall here. So come back to the manufacturing. We can just generate these. We have our same toolpaths, and I'll just say that these work correctly. Let's say, since we now have this wall that we want to rough away and finish, an easy way to do that would be to just take this toolpath and duplicate it, edit it, change the geometry from this chain to this chain, and hit OK. So now we're going to come down, do 2 roughing passes and a finishing pass, right? Well, let's actually observe what happens. So we know this one's right. And we're starting our second roughing pass here. And tool comes down, starts its first roughing pass. But for some reason, it has decided to do this pass at the finish feed rate. This is not going to be the end of the world, but it is going to take twice as long doing these roughing passes because it's going at half the speed. It starts its second roughing pass here. It remains at the finishing feed rate. And it comes around to where it's actually doing the finishing pass. And, good, it does it at the finish feed rate. Comes out, and then it starts this toolpath, which we know is already good, the floor finishing. Okay, so, that's interesting. So basically, these 2 operations are identical. But when this one comes down, it starts at a roughing feed rate. And this one starts at, hopefully I got the word right, but basically the first one starts correctly, roughing feed rate. This one does the finishing feed rate. So that's no good. So there's a workaround for this. Wait, is there? Hold on. I think the only workaround I can think of for this is you would basically duplicate this again, edit the last one, remove the roughing passes, then edit the first one, keep the roughing passes. Okay, no, actually, you'd cut the roughing passes down to 1 less, then convert your finishing feed rate to a roughing feed rate. And now I think we're good. So let's watch it. The tool comes down, it's at the roughing feed rate, 1 roughing pass, 2 roughing passes, both at roughing feed rate. Comes up, starts the now second operation, which is going at the finishing feed rate. So, not the end of the world, but if you didn't know this was happening, you might not, know to fix it. All right. So basically the opposite happens with 2D contours when you have it doing multiple finishing passes. So the keen-eyed among us may have noticed that I've actually got a little bit of stock here above the part. So in real life, you'd also want to do a finishing pass on the outside here. So an easy way to set that up is I can just duplicate this and then switch my geometry over and hit OK. And instead of showing the whole thing, let's just look at this one only. So the tool comes down and starts what should be its first finishing pass, but instead it's going at the roughing feed rate of 100 millimeters a minute. So it roughs around here, continues to rough around to there, and when it comes around to what should be the third of 3 finishing passes, it finally starts actually going at the finishing feed rate for the final pass. So the workaround for this one is you go in and edit the feed rate at the tool. The way I like to do that is edit the expression and multiply it by 0.5. I do it this way because sometimes the number here is in a different, I work in metric, but the tools are imperial. So this feed rate in here will sometimes say like 4, what is it? Say IPM? It'll say like 4 inches per minute. Well, I don't remember how it, anyway, if the tool is set up as an imperial size tool, it'll say inches per minute here. So multiplying it by 0.5 does exactly what you want. And it preserves the original tool feed rate. Okay, so multiply by 0.5, that drops it to 50 millimeters a minute. I'm trying to do finishing passes here, so 50 is correct. And then we have to come into our passes and change our finish feed rate so that it does the full, what is now set to the cutting feed rate, so that it does a consistent 50 millimeters a minute the whole time. So now this is 3 finishing passes, and all 3 are at the finish feed rate, even though it knows it's finishing here, and for some reason thinks it's cutting here, which is wrong. Okay, so we've got some workarounds here. Well, now the problem with the second workaround is we've basically changed... okay, forgive me if this doesn't happen. I haven't actually done this on video yet, and I don't want to edit it out. But we've essentially changed what it thinks we want the tool to do. So if I create a new 2D contour, and I guess just for kicks, okay, we can already see the cutting feed rate here is set to 50. That is, of course, not the cutting feed rate of this tool. This tool is supposed to cut at 100. So let's create this tool path real quick, and let's just see what it does. All right, it is going at 25 millimeters a minute. So for some reason, it has adopted this value from the operation before it, but it has preserved the default unit here, the default expression for the finished feed rate. So to fix this, if you didn't notice this happening, it would be really easy to just, continue to not notice, I guess. And it would cut, and it would probably look fine and probably look pretty good, but really it would be taking twice as long as it needed to. So how do you fix this? There's a few ways. It's pretty obvious, but I kind of want to go over what I've noticed, and maybe somebody watching this will tell Autodesk to fix their stuff. So the most obvious thing you can do is you just change your expression. Oh, look, it's set to 50 for some reason. So I guess, yeah, really, it's not as obvious as I thought it would be. So I guess you could come in here. If if you know what's happening, you could just multiply by 2. There you go. Back to being fixed. Awesome, right? Another thing you could do is you might think, all right, I can reselect the tool from the tool library and, maybe I'll reset it this way. So I have one tool in the library, and if I select it again, I might expect it to reset, but when I hit OK, it does not reset. It has retained that, the kludge fix that I did for the operation before, it is now applied to this new operation. And since I have no other tools in the library, I can't select a new tool. So now in order to reset the tool, what I have to do is create a new tool, apply that to the tool path, then come back and select the old tool, the one I actually want to use, put it back, and now we've got it reset to the cutting feed rate. And since this would ostensibly be a finishing pass, now our finishing pass is going at the right speed again because of the default expression. So, I guess this bug begets annoyances, and it's just, it's pretty annoying. So this will now machine kind of properly at the proper feed rates, and everything is good. And when I come in and make another 2D contour, the tool isn't using some stupid feed rate, it's using the correct tool feed rate. But only because I put this one in the middle. Just for kicks, let's delete this one and create another one. I don't know if it's adopting this feed rate because it was the most recently created one or the most recent one in the list. So let's try a new one. So now we've got the same tool, and sure enough, set to 50. So, in this case, I guess let's try this. Okay, we'll create this one. We'll use this ball mill for a second. And come back to this tool. So now this is reset. So this is 100. Let's hit OK. I'll create another one. And I guess I didn't need to select that. So now this is OK still. Let's say I rearrange my toolpaths here. Put this one on the bottom. Create a new 2D contour. And there we go. Our feed rate is wrong again. So this is just a recipe for screwing up your part. It's not too hard to imagine that you might, maybe one of these 2D contours, you might come in here and be like, I'm barely taking off anything. I want this tool to go at mega speed. And, you're probably never going to multiply it by 10, but let's just do it. Got it set to 100 here. Create another toolpath, and now our tool's going, this crazy speed. Let's say we even notice it. Do the multiple step fix for it. Now we're back at the right speed. But then you come in and you rearrange your toolpaths. Put this one on the bottom again. Create another 2D contour, and our tool's going at this crazy speed. This is really no good and really should be fixed. And I actually didn't even, whatever. I think it's probably good that these are all out there. Okay, so I think I promised a bonus bug. If I didn't, here comes one. Another thing I noticed is the tool library is just really insistent that you have a tool holder on your tool. And if you try to tell it to take away the tool holder, it's not having it. So to take it away, you can hit the X here. It comes up with a warning. It's like, are you sure you want to change the tool holder? It's like, yes, I'm sure. Thanks for, thanks for making me hit this extra button. Not the end of the world, but okay. So hit OK. There, we have a tool holderless tool. Perfect. Hit OK. It does not know anything has changed. And if we look at the toolpaths, that old tool holder is still on here. So maybe you got to regenerate it or something, right? So regen, tool holder is still on there. So it doesn't know. So let's try this. Let me switch to this tool. And then go back to this tool. See what happens there. Okay, hey look, the tool holder is back. So it has like forgotten that it took the tool holder away in the tool library, and you know, it's put it back for me. Thanks, bud. So what you can do is you can come in here, edit the tool while editing an operation, take the tool holder away, and now when you create it, the tool holder is gone, but only in that one, because in the other tool paths it is still, it remains. So maybe if I regen this one, okay, no, so maybe I'm like, all right, I want to fix this one. Come in, take the tool holder off of this, and hit OK. Well, when you do that, this toolpath now has figured out that you have messed with it and has put the tool holder back onto the tool, which is just like, it's baffling. Why is this not being saved in any, in a meaningful way or whatever? All right, cool. So hopefully this has been helpful. I forget if I mentioned this a long time ago. I did report this bug to Autodesk, but I only sent it through an email. I think that email at least reached a couple people. I even made a video for them so that, it was real clear what was happening. And my recollection is that they acknowledged that it existed. I think they were able to recreate it, but I guess it got lost or something. So, and also that was back in July of 2017. So, like, they've had time to fix this, and one way or another hasn't. So, knowledge is power. Hopefully, at least by sharing it, other people will be able to avoid the series of bugs that I've shown here. Alrighty, cool. Thanks for watching. I'll see you guys later.